Yes. Good afternoon, learners. Let's take one more numerical problem from the chapter the structure of atom. The question is saying if the wavelength of the first line of Paschen's series of the hydrogen atom is 720 nanometer, then the wavelength of second line of this series is dash nanometer. The first line is this. What will be the second line? The wavelength. And this question was asked in 2023, the joint entrance examination mains. So here we need to find out the wavelength. And what you are given is the wavelength of the first series. So you need to understand how what is this Paschen series first. The Paschen series is a spectral line for hydrogen atom. There are other series also, like Lyman series, then comes Balmer, then Paschen. This is asking about Paschen, then bracket, then P-Fun series. The lines in the Lyman series will all be ultraviolet, which cannot be seen with your naked eyes. The line for Balmer series will be in the visual range. We can see it. In the Paschen, bracket, and P-Fun, all these lines of hydrogen atom, they belong to infrared radiation. They are not visible to our naked eyes. And what's happening is in Lyman series, the electron will jump to higher orbits, and it will come back to the first orbit. It may be from second to first, from third to first, from fourth to first, or fifth to first, but it will jump to the first. It will jump to the first orbit. So whatever the difference in energy, it will come as electromagnetic radiation. And similarly for Balmer, whatever be the electron will jump to the second orbit from any higher orbit, from 3 to 2, or from 4 to 2, or from 5th to 2, or from 6 to 2nd, like this. But in Paschen series, the electron so similarly for Paschen series, there are those series of spectral lines in which electromagnetic radiations are emitted by the hydrogen atom when an electron jumps back from the fourth orbit to the third, from the third to the third orbit. The final orbit will be the third orbit. From fourth to third, or fifth to third, or sixth to third, or seventh to third, it will come back to the third orbit. So whatever difference in energy is there, it will come out as electromagnetic radiation from it. Okay, then what is a mathematical relationship according to which we will be able to find the wave number? The wave number means the number of wave in unit length, in 1 centimeter or in 1 meter, is given by RH into 1. The general formula is 1 by n1 square minus 1 by n2 square. This will be the last orbit, the final orbit. This will be the higher orbit compared to this. So in our case, according to our question, the final orbit will be, since it is given as Paschen series, it will be 3. So we replace this by 3 square, right? And what is this? This is Rydberg constant. Its value is 109677 per centimeter. But since the question has not given you this value, and instead of it, they have given you the wavelength of the first line of the Paschen series as 720 nanometers. So you are supposed to use this wavelength and calculate the second wavelength. Compared to this, you have to calculate the second wavelength. So you have to make a relationship or generate an equation of comparison, so that you can calculate the second line compared to the first line. So you are not supposed to know the Rydberg constant. Without using the Rydberg constant, you're going to calculate the wavelength of the second line. So wave number is what? It's actually reciprocal of the wavelength. So wave number equal to 1 by wavelength is equal to this. Although originally it was given like this, the wave number equal to Rydberg constant to 1 by n1 square minus 1 by n2 square. N1 is the last orbit to which electron will come back in hydrogen atom, and N2 will be any other higher orbit. So what we are going to do is we're going to, instead of writing the wave number, we will write in terms of wavelength. So 1 by wavelength equal to this, right? So wavelength will be what? Will be reciprocal of this. Now for say suppose we do not know the wavelength of the first orbit, how will you do it? Let lambda 1 be the first orbit. So now one more thing, what you need to know is what is the first line and what is the second line. First line, what is the first line for Paschen series? What is the first line? First line is the line is line with the longest wavelength. It will be the longest wavelength, right? And there's 720 meter. So what this means is that it is the electron jumping from the just one more higher orbit to the third orbit. So it's coming from fourth to third. This one is when the electron is jumping from fourth orbit to the third orbit. And what you are supposed to calculate is the wavelength when the electron jumps from fifth to third. Fourth to third is this. Fourth to third will be considered as like somehow electron is going to jump to the third orbit, right? And then that's why it's called Paschen series. The first line will be from fourth to third. The second line will be from fifth to third. The third line will be from sixth to third. That is how the first line, second line, and third line means for Paschen series. Similarly, for Lyman series also, there will be first line, second line, third line. What will be first line? The electron will jump from second to the first. What will be second line for Lyman? The electron will jump from the third to the first orbit. What will be the third line? From fourth to the first orbit. That is how the first line, second line, and third line means. So here you need to understand what's the first line. You need to know the Paschen series, and you need to know the relationship of the wave number and the wavelength and how is wave number calculated. You need to know when you know the equation, you need to know what is Rydberg constant. But somehow for this question, say for the first series, let it be denoted by lambda 1. Its value will be here 1 by 3 square minus 1 by 4 square. And lambda 2's value will be 1 by lambda 2 equal to RS 1 by 3 square minus 1 by 5 square. So this is the lambda 2's value. Why this is a reciprocal? Because see, this is wave number is directly proportional to this, but wavelength number is inversely proportional to its reciprocal of wavelength. So when you are writing wavelength, its value will its value get reversed because it's reciprocal. Its value will be here, its value will be here, right? Lambda 1's value will be up and lambda 2's value will be down. We want to calculate lambda 2, the second line, right? So for second line, these are the value. For first line, these are the value. And in the meantime, the Rydberg constant will get cancelled. So there is no need to know the value of Rydberg constant. That's what the question wants you. The question doesn't want you to use the value of Rydberg constant. So here we go. Now in case 1 by 9 minus 1 by 16, 1 by 9 minus 1 by, this will be for first line and this will be for the second line. But you know the value of lambda 1 is already given 720 nanometer. You bring it here. So whatever the ratio is, you simplify it, multiply by 720 nanometer. So the answer will come as 492 nanometer. It is slightly shorter than the first line, the wavelength. So this is how you're going to calculate this. I hope you understand.